Good morning everyone and welcome back to my channel. Today we will see how to obtain this pattern, hexagonal pattern on a flat surface. And naturally, as usually, this is not a static model but is a parametric model. You can control it by using this Grasshopper that can increase or decrease the level of bump of the pattern, but you can also modify the pattern itself. For example, you can amplify the number of hexagon in this in the same area. So for example, you can use maybe 14 hexagon instead of 12, and you will see that the pattern will automatically modify itself. Naturally, you can also extreme this number, and then you can play with the Grasshopper to obtain the right result you want. Maybe this is acceptable. So let's go to the definition. Just a moment in order to reset the parameter to the starting ones. Perfect. Okay, this is our final results. We shift to shaded view in order to see what we are doing with each passage. First, we import a rectangular curve that it will be our boundary curve. Then we create a boundary surface, and then we offset this surface of an amount. I said 100, and then from this offset surface we create using this hexagon cells that is a command of a lunchbox that you can download from Food for Rhino. It's very useful kit. Then we create these hexagonal cells, and we set 12 as input for the U and V input button. Then we come back to the starting surface, and we divide the surface, and we individuate on the surface 47 points in U direction and in V direction. Now we are going to use this common pull point. That's very interesting, and it works with a grid of points, and it try to find into the cells, so into our input geometry, the points that are next to the grid of point we selected before. So it takes the grid of points as first input, and as second input takes the geometry. In this case we give the cell geometry, and so the results is this. And for every point of the grid correspond another point of this this collection of points. And as output we have the distance between the starting point and the projected one. Okay, so then we will use the distance in order to evaluate the amplitude of the movement we will have to give to the point, but we'll see better. Then we start from the pull point, and we want to take the starting point and then move them of a vector. The vector will be a vector between 2 points, from the first point that are the points of the grid to the second point that are the pull point. we want to evaluate so this direction, and once we evaluate this direction, then we take just the unit vector in order to eliminate the amplitude of the vector itself, and then we are going to use this amplitude that takes the direction and takes an amplitude. Which will be our amplitude? We will see now. What we do, we take the distance from the pull point to the starting point, and we are going to divide this distance, divide 100 for this distance in order to obtain a number that is between 0 and 1. Okay, now we have this collection of number. We enter into a graph mapper in order to control the in order to control graphically the results, and then we use a multiplication amplifier here in order to control the effect with a slider. Then we connect this result of the result of this multiplication directly to the amplitude of the vector that we saw before. And now we have the vector, we have the starting point. We only need to move the points derived by this collection of vectors. And so these are the final points we need. And now we only apply this command that is this comes from flexibility plugin. That is a very useful plugin that you can download from Food for Rhino. And this create this kind of surface here that we see in the first part of the video. So you can control this surface from the graph mapper here, from the amplifier here, and for the U division here in order to increase or decrease the number of hexagons into the surface. Okay, the definition is complete. I only apply this custom preview in order to have a good effect, and see you in the next video. Thank you very much and have a nice day.